Preparing for a DevOps engineer at Kyndryl interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design a CI/CD pipeline for a large enterprise application? I would build the pipeline around repeatable, gated stages: commit, compile, unit test, security scan, package, deploy to a temporary environment, run integration tests, and promote through staging to production. Artifacts would be immutable and stored centrally, while infrastructure would be versioned as code. Production releases would use approvals, canary deployment, health checks, and automated rollback. For Kyndryl clients, I would also integrate ITSM change records and preserve audit evidence across cloud and on-premises environments. While answering, cover source control, build automation, unit and integration testing, artifact repositories, security scanning, environment promotion, approvals, rollback strategy, observability, and how you would support hybrid cloud enterprise requirements. Question 2. What is the difference between continuous delivery and continuous deployment? Continuous delivery means every change passes automated validation and remains ready for production, but a person or business process may approve release. Continuous deployment goes further by automatically releasing every validated change. I prefer delivery for regulated or high-impact enterprise systems, where approvals and maintenance windows matter. I use deployment when tests, monitoring, rollback, and feature flags provide strong protection. The right choice depends on operational risk, compliance obligations, and customer expectations. Make sure to explain that delivery keeps software production ready while deployment releases automatically, then discuss testing confidence, business approvals, risk, compliance, feature flags, and when each model suits enterprise clients. Question 3. How would you implement infrastructure as code for hybrid cloud environments? I would use Terraform with reusable, versioned modules for networks, compute, identity, and managed services. State would reside in a secured remote backend with encryption and locking, separated by environment and client boundary. Pull requests would run formatting, validation, plans, security checks, and policy tests before approval. I would detect drift through scheduled plans and reconcile only through code. Provider limitations would be handled with controlled modules or configuration management steps, keeping the desired state auditable. In your answer, discuss Terraform or equivalent tooling, reusable modules, remote state, locking, secrets management, drift detection, policy enforcement, environment separation, code review, and consistent provisioning across on-premises and public cloud platforms. Question 4. How do you manage secrets securely in a DevOps pipeline? I never store secrets in repositories, pipeline variables in plain text, images, or logs. I use a secrets manager such as HashiCorp Vault or a cloud-native service, with workload identity and short-lived tokens. Pipelines retrieve secrets only when needed, inject them at runtime, mask output, and record access for auditing. Rotation is automated wherever possible, and permissions follow least privilege. If a secret leaks, I revoke it immediately, investigate exposure, and update the control. Be sure to mention vault-based storage, short-lived credentials, role-based access, encryption, rotation, masking, secret injection at runtime, audit logging, separation of duties, and preventing credentials from entering source code or build artifacts. Question 5. What deployment strategies would you use for a critical production service? For a critical service, I would usually choose blue-green or canary deployment. Blue-green provides a complete parallel environment and fast rollback, but temporarily doubles infrastructure cost. Canary releases expose a small percentage of traffic first, allowing comparison of latency, errors, and business metrics before expansion. I would keep database changes backward compatible, automate health gates, and define rollback thresholds beforehand. For stateful legacy systems, a carefully controlled rolling release may be safer. Cover rolling, blue-green, canary, and recreate strategies. compare downtime, infrastructure cost, rollback speed, database compatibility, traffic control, health metrics, and suitability for critical Kyndryl managed services. Question 6. How would you troubleshoot a failed deployment in production? I would first stabilize the service by stopping promotion, assessing customer impact, and rolling back if the previous version is healthy. Then I would correlate deployment timestamps with logs, metrics, traces, configuration changes, and infrastructure events. I would compare the failed artifact with the last known good release and reproduce the issue safely. Throughout the incident, I would communicate status and ownership clearly. After recovery, I would document the root cause and add an automated prevention check. In your answer, explain incident containment, change correlation, logs and metrics, recent artifact comparison, health checks, rollback, communication, root cause analysis, evidence preservation, and preventing recurrence through pipeline or process improvements. Question 7. What is your approach to monitoring and observability for distributed systems? I separate observability into metrics, logs, and distributed traces, connected through a request or correlation ID. I define service-level indicators such as availability, latency, error rate, and saturation, then derive objectives and alert thresholds from user impact. Dashboards show dependencies and deployment markers, while alerts are actionable and routed to the correct team. Centralized collection must work across cloud and data center systems. I also review alert noise regularly because untrusted alerts damage incident response. Make sure to cover metrics, logs, traces, correlation IDs, service-level indicators, error budgets, dashboards, alert quality, dependency visibility, centralized tooling, and actionable monitoring across hybrid infrastructure. Question 8. How would you containerize and operate an enterprise application? I would create a minimal multi-stage image, run as a non-root user, pin dependencies, and scan it for vulnerabilities before publishing to a trusted registry. Configuration and secrets would remain outside the image. In Kubernetes, I would define requests, limits, readiness and liveness probes, disruption budgets, autoscaling, and centralized logging. Images would be promoted by digest through environments rather than rebuilt. For stateful workloads, I would evaluate managed services or carefully designed persistent volumes instead of forcing everything into containers. Discuss image design, multi-stage builds, non-root execution, vulnerability scanning, registries, resource limits, health probes, configuration separation, orchestration, persistent data, logging, and controlled image promotion. Question 9. What Kubernetes issues have you troubleshot, and how did you resolve them? A practical example is a deployment stuck in crash loop backoff. I start with pod status, events, container logs, and the previous container's logs, then verify configuration, secrets, probes, resource limits, and dependency connectivity. If the application is healthy but unreachable, I inspect services, selectors, endpoints, network policies, and ingress rules. I compare the rollout with the last working revision and use rollback when appropriate. I fix the underlying configuration, then add a test to catch it earlier. Be sure to mention a systematic workflow using pod events, describe output, logs, probes, scheduling, resources, networking, configuration, service discovery, rollout history, and safe remediation rather than guessing. Question 10. How do you integrate security into the DevOps lifecycle? I treat security as an automated quality gate rather than a final handoff. Pull requests run secret detection, SAST, dependency checks, and infrastructure policy validation. Built images receive vulnerability scans, and deployed applications receive DAST where practical. Threat modeling identifies higher risk paths before implementation. IAM follows least privilege, with short-lived credentials and auditable access. Findings need severity-based gates, ownership, and documented exceptions, so teams can deliver quickly without silently accepting unacceptable risk. Cover shift left practices, SAST, DAST, dependency and container scanning, IAC security, secret detection, least privilege, threat modeling, compliance evidence, exception handling, and balancing risk with delivery speed. Question 11. How would you manage configuration across development, test, and production? Application code should be identical across environments, while environment-specific values are injected through versioned configuration or a parameter store. Secrets remain in a vault and are referenced, never copied into configuration files. I would validate schemas and required values during deployment, review changes through pull requests, and promote configuration with the release. Production access would be controlled and audited. This approach reduces hidden differences and makes failures reproducible, while allowing each client environment to retain necessary policies. In your answer, distinguish code from configuration, describe environment-specific overlays, centralized parameter management, secret separation, validation, versioning, promotion, drift prevention, and avoiding unreviewed manual production changes. Question 12. What is GitOps, and when would you recommend it? GitOps manages declarative infrastructure and application configuration in Git, with an agent continuously reconciling the environment to that desired state. A pull-based controller improves auditability, limits direct cluster access, and automatically corrects drift. Rollback is usually a Git revert. I would recommend it for Kubernetes and environments with stable declarative APIs. I would not force it onto systems requiring complex manual procedures or unsafe state transitions. Those need carefully bounded automation around the GitOps boundary. Explain declarative desired state, Git as the source of truth, pull-based reconciliation, controllers, auditability, rollback, drift correction, secret handling, and limitations for legacy or highly procedural environments. Question 13. How do you improve pipeline performance without reducing quality? I begin by measuring stage durations and queue time, then optimize the largest constraints. Independent unit, lint, security, and packaging jobs can run in parallel, dependency caches and incremental builds reduce repeated work. I keep a fast test suite on every commit and run broader integration or performance tests at suitable gates. Artifacts are built once and reused. I would never remove meaningful coverage merely to improve duration. Pipeline performance should increase feedback speed while preserving confidence and traceability. Discuss measurement first, parallel execution, dependency caching, incremental builds, test categorization, reusable runners, artifact reuse, early feedback, quality gates, and maintaining reliable security and integration coverage. Question 14. How would you design an automated rollback mechanism? I would retain immutable release artifacts and record the last known good version for every service. During rollout, automated gates would watch error rate, latency, saturation, readiness, and key business checks. Breaching defined thresholds would stop expansion and trigger rollback or require approval, depending on impact. Database migrations must be backward compatible because application rollback cannot safely undo every schema change. I would notify responders, preserve evidence, and rehearse rollback regularly so it remains dependable under pressure. Make sure to cover immutable versions, health criteria, deployment history, automated thresholds, stateless and stateful rollback differences, database compatibility, approval boundaries, notification, and validating the recovery path regularly. Question 15. What is the role of ITIL and change management in DevOps? ITIL provides operational discipline around incidents, problems, changes, service ownership, and customer impact. DevOps should automate low-risk standard changes, capture evidence automatically, and reserve human approval for higher-risk releases. I would connect pipeline records to the change management system, include testing and rollback plans, and use post-incident reviews to improve controls. The goal is not slower delivery, it is predictable, auditable delivery. For Kyndryl clients, that balance is essential across managed and regulated environments. Cover change classification, standard versus normal changes, approvals, risk assessment, incident and problem management, auditability, automation, and how DevOps can improve control without creating unnecessary bureaucracy. Question 16. How would you handle a zero-downtime database migration? I use an expand and contract approach. First, I add nullable or backward-compatible schema elements, deploy code that can work with both versions, backfill data in controlled batches, and validate consistency. After traffic uses the new path, I remove obsolete fields in a later release. Large migrations may require replication or dual writes, with reconciliation checks and a tested backup. I monitor lock time, replication lag, error rates, and performance. Database rollback is often harder than application rollback, so compatibility matters. Discuss backward-compatible schema evolution, expand and contract migration, dual reads or writes, data validation, replication, traffic control, rollback limits, backups, observability, and coordination between application and database teams. Question 17. How do you manage reliability and disaster recovery for enterprise services? I start with business-defined availability, recovery time objective, and recovery point objective. Then I map dependencies, remove single points of failure, configure backups and replication, and choose multi-zone or multi-site architecture appropriate to the requirement. Recovery procedures belong in versioned runbooks and should be tested through realistic failover exercises, not merely documented. Monitoring must detect backup failure and replication lag. I would report results to the client, track gaps, and continuously improve recovery confidence. In your answer, cover availability objectives, RTO, RPO, backups, replication, multi-zone or multi-site design, dependency mapping, runbooks, failover testing, monitoring, and client-specific business continuity requirements. Question 18. Describe a time you automated a repetitive operational task. In one environment, engineers manually validated server patch status across hundreds of machines, which was slow and inconsistent. I created an Ansible workflow that gathered versions, compared them with the approved baseline, generated an exception report, and opened tickets for non-compliant hosts. It used inventories by environment, vaulted credentials, dry run mode, and logging. The process reduced a day of manual work to minutes and improved audit evidence. I documented ownership and added scheduled execution with failure notifications. Be sure to structure the response with situation, task, action, and result. Quantify time or error reduction, explain technologies and safeguards, and mention documentation, ownership, and measurable operational improvement. Question 19. How would you troubleshoot a sudden increase in application latency? I would confirm the latency increase using percentiles rather than averages, identify affected endpoints and environments, and check deployment markers, infrastructure saturation, database performance, queues, and external dependencies. Distributed traces help locate where time is spent, while logs reveal errors or retries. I would mitigate through rollback, scaling, traffic shifting, or rate limiting based on evidence, and communicate impact and next steps. Afterward, I would identify the root cause and improve alerts, capacity, or test coverage. Cover symptom confirmation, dashboards, percentiles, traces, recent changes, saturation, database and network dependencies, comparison by region or version, mitigation, communication, and root cause prevention. Question 20. How do you collaborate with application, infrastructure, security, and client teams on a DevOps engagement? I establish shared objectives first: reliability, delivery frequency, security, cost, and customer outcomes. I define ownership through service maps, runbooks, escalation paths, and measurable service level objectives. Regular design reviews and demos expose assumptions early, while incident work uses clear roles and blameless learning. With clients, I translate technical trade-offs into risk, cost, and business impact, then document decisions and provide knowledge transfer. Effective DevOps is collaborative operating design, not simply installing tools. Mention shared ownership, clear interfaces, service-level objectives, documentation, communication cadence, stakeholder translation, incident roles, requirements discovery, knowledge transfer, and adapting practices to each client's operating model. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.